So let me check on YouTube whenever it starts streaming. Yeah, I think it should be fine. Start streaming. Yeah, it works. Okay. We are live now. Hi, how are you doing?
Hi, Matt. I'm doing great.
So yeah, like good talking to you. So we have the YouTube chat and the Twitch chat. So before we start, like if you're watching this and there is anything like that's not working, like the sound, or if you spot any issues, like please do not hesitate to just type it in the chat so I can fix it as we go. Since I didn't touch that streaming software in quite a while, I just want to make sure like everything is okay. But yeah, so that's pretty much it. So yeah, so how are you doing today?
We are all well today, I believe, and I can speak for everyone who's on chat today. Thank you for joining in for this session.
No worries. So yeah, what should we talk about today?
Oh, I think
I'll let you lead the session.
based on our conversation earlier, I wanted us to focus more on malware analysis, and I have a set of some items that you could touch on for this session. So maybe a little background to everyone who's on our page right now. This chat stemmed from a Darknet Diaries episode on the podcast series that is done by Jack Resider on Darknet Diaries. So with that, Matt recorded a session on the WannaCry virus that had stemmed out a couple of years ago, and that's how we now picked up this conversation to chat more about the same. So with regards to that, maybe I could direct you to where you could pick a few sessions on podcasts. So the podcast series that I could recommend for hackers is Darknet Diaries. And over to you, Matt.
I was posting the Twitter message saying we're live. Yeah, so it is a pretty good podcast. I think like the Darknet Diaries and Security Conversation with Ryan Naren are like my two favorite podcasts too. The pretty good ones. But yeah, that was a pretty good episode. I sent it to a bunch of like my friends who don't work in IT. They also enjoyed it, which is quite rare. Every time there is like an IT podcast, like most of the people who are like interested is mainly the IT people. I should out. Just posting the message on Twitter and boom. But yeah, so yeah, it was a good episode. So in that episode, we're talking about like the background story about WannaCry. Although it is quite old now. Like WannaCry was 3 years ago, and yeah, it was like 3 years ago. One sec. Yeah, we I think we're back online. Yeah, it was 3 years ago, and people are still talking about it. I don't know, like in Kenya, like are people still talking a lot about WannaCry or?
Yes, there's still more conversation around it, and I believe some of the different organizations are still having issues with that.
Oh, really? And do you see like a lot of ransomware attacks happening in Kenya, or is it mainly like the same one that we see abroad, or have you seen like Kenyan specific like ransomwares?
Not really prevalent, but the more attacks that we receive mostly is around social engineering.
Mm-hmm.
Yeah, that is what is most prevalent because of what people use right now is the use of mobile money across the different platforms we have. Yeah.
Do you see a lot of phishing attacks too?
Yes, a lot more of that now.
From any specific countries or just like really random?
Pretty random for that one.
Okay. Because here we see a lot of like phishing attacks from Nigeria, funny enough. Like even like a few months ago, there is someone called the Hush Puppy that got arrested. I don't know if you saw the news. It was pretty entertaining. But yeah, cool. Yeah. So yeah, so do you want to proceed with the discussion? Like, should we start with some specific question that you have, questions from the chat, or because I don't want to like spoil the podcast episode either, you know, otherwise people won't listen to it. So what do you think would be the best approach?
I think we can start with the questions on chat, but before that, maybe you could tell us more about how you started this journey of malware analysis and focusing more on these viruses that are coming up in this industry of ours.
Okay. So, I mean, since I've been doing reverse engineering for like 15 years now, I guess, it adds up quickly. I think I started reverse engineering when I was like 14 because I got involved in the cracking scene. And back then, so it was like the best way to learn reverse engineering by looking at like softwares, writing keygens and those things. So then transitioning to like malware analysis is very straightforward because it's much simpler. And that's how I kind of continued to do like more reverse engineering for like software security. And yeah, every now and then there is always like some malware that's worth looking at. But when the shadow brokers like released a lot of files, that was a very a special time because yeah, a lot of like exploit and tools that were worth being analyzed got leaked, and obviously like a bunch of exploits like ethanol blue, backdoors like double pulsar that were later on like reused in ransomwares like NotPetya or WannaCry. So it's kind of like how the journey happened, you know. There's always like something being posted on Twitter that's worth looking at, and then you look at it, and then you fall into a rabbit hole.
Yeah, I think that's a very interesting journey, and now I believe for people interested in malware analysis, maybe they could take your path, or they could just dive into malware analysis. Yeah.
I mean, don't do like software cracking, but definitely learn reverse engineering. But it does help. Like reverse engineering is good because it helps with software development. Actually, like if you want to become a software engineer, I think like reverse engineering is a pretty good skill set because you do understand how like the machine and softwares are working in general. So it gives you like a good layer of abstraction that you can use for like the future.
Okay. So if I want to go to malware analysis, that means, or even software development itself, I could focus more on reverse engineering to get better at it, and then that's how best I can now dive into malware analysis and anything to do with software engineering, but not assuming. It could be a nice path. At the same time, it's something that is quite beneficial to us on that. Yeah.
Yeah, no, definitely. Because software engineering, there's so many like new languages like appearing all the time now. Like now, like the one that everyone is talking about for like the past like 2 years is Rust. So if you know, like if you want to learn Rust, I think like I'm not saying that reverse engineering helps, but you know, like the core concept of some like programming languages definitely help you. And at least with reverse engineering, you like focus on like the core things of how software is working, so you kind of know what's gonna be the output of like a programming language.
Okay, I think that's pretty understood. And there's also the Go programming language that have really had a lot of hype with regards to security professionals.
Yeah. So I think Rust is becoming more popular than Go, like slowly and slowly, but Go is still like fairly popular. Like I mean, like Go and Rust are probably the top two like appraising languages now for like for a bunch of stuff like locally and web development and everything. So which is like quite neat compared to like Node.js, which is like slowly and slowly not disappearing, but people are like getting fed up of it because it's very hard to troubleshoot.
Makes sense. Yeah, I believe we can now proceed to the next step of the different questions we had for this session.
No problem.
Okay, so maybe I start with the first one. What are the different ways we could detect malware in our systems or applications? And more like on the side of application, because users will always have mobile applications and they have different application softwares, and at times it could be malicious, but it's out of their knowledge to note that.
Yeah, it's like the question is simple, but at the same time very interesting, because in the case of like those ransomware attacks, the only reason people knew they were infected is because in the case of WannaCry, you have this like massive like red pop-up, your files are like encrypted, then people know they've been infected. But imagine if you remove that pop-up and the files are not encrypted and people are stealing your documents, you could assume like all of those people would have no clue of what was going on, and they would not know there have been that there is a malware on the system. So it depends like from which aspect. In theory, like most of antiviruses and EDR are supposed to detect like those threats, especially if it's something like quite well known that has been spreading like like multiple countries, multiple companies. And by that time, like researchers would know what the signature look like. But now how companies do it is like a lot of security companies, like in general, have millions of endpoints. So they have antiviruses or like EDR installed on millions of machines. So they get a lot of telemetry data reported back to them. So on events and like type of files being run and executed, etc. So if you're a large company, then if you have access to that type of information, then you can use leverage the telemetry to like map like malwares and attacks even without analyzing them, because you're like, oh, this is unusual based on the behavior, and your endpoint will detect it, and then the software vendors can like start to look at it. So that's basically like like malware detection is happening. And every time you see like a big security company publishing a new like blog post or article about a new malware saying, oh, this is what we have found, and but that's basically what they find it, because they have a lot of telemetry. Yeah,
that's a good step. And maybe you tell us more about the EDR solutions, because I've seen it's more also you can use it for different cloud services that you have.
Yeah, it's a good. So most of the EDR now is kind of like they're trying to replace antiviruses in a way, and then they report back some data, like some logs, on what's happening on the system to like your platform. I think they're quite expensive, so like the public is not really. The mainstream like users are not using them, So it's mainly like large companies, even like some like EDR companies are just focusing on large accounts. But even in terms of like blocking attacks, they don't always block them, and they can always still be bypassed. But they became very popular over the past like 5 years. But they are still heavily like Windows oriented. So when it comes to like Mac or Linux, there's still a huge gap. There's like, and you could say the same thing for like incident response or like threat hunting. It's always like heavily Windows dominated. But yeah, so that's basically like what EDR would be doing. And yeah, there's quite a lot of like EDR vendors now.
Okay. Because it's something I learned about this year, despite its existence for five years now.
Oh,
So
EDRs. I mean, yeah. I mean, but at the same time, you know, like I understand you because I also find it very confusing. Every time there's a new like acronym popping out, like EDR. Now people are talking about XDR. You know, like I was asking on Twitter last time, what's an XDR? You know, like, and then there's like the MDR. Malware detection and response, then like all those like new acronyms, but at the end of the day when you look at what the platform or software really does, it's much simpler. Just like always new acronyms, like it's like I personally also find it like very difficult to like follow, because like it's like, okay, what does it do, you know, like and yeah, I also find it very confusing, to be honest. And which is a bit of a shame, because security like is becoming like complicated for like a bit no reason, you know. It's like a mix between like marketing people, you know, adding new acronym to create like their own technical bubble, just so like there was some sort of like legitimacy or something. But then if you look at the actual solution and what it does, you know, like it's much easier to explain. And I find like the industry is becoming more and more confusing. Sometimes that people like explaining stuff to me, like when we're having discussion, like I was like, yeah, but that's in theory. It's not actually doing it, you know, because I know actually like also the software would be working, and then they like come up with all those like acronyms and everything. I was like, oh, I think you lost me here, you know. So yeah, I cannot blame you. I'm the same.
Yeah, because I think it's now complex to really find a solution that works for you, because there's so many options and you're like, what's the best thing I can use right now, or what would be the best option I can go with right
Yeah.
now?
Also, it depends of the profile of the company, like the maturity of the company. I mean, you like I guess in general you want to be able to have like as much logs as you want and to be able to search it like quite efficiently.
Yes.
But a lot of the times you not have like all the information you want from logs. You know, that's why like we're pushing a lot for like memory analysis if you want to do like threat hunting, pushing for a platform and everything, because like not everything can be found in the logs, you know, especially if you're like a bank or a telco company. But in reality, most of companies will still be like at like, yeah, like if infosec would be a game, you know, they will still be at like level 1 of like, okay, we're trying to collect logs, you know. So it is a bit tricky.
Yeah. Yeah. I think we've really discussed that part of it well and comprehensively right now. So maybe we can go to our next one. At best, we can discuss on how best do we perform dynamic analysis on malware.
I mean, step 1 is like understanding assembly, you know.
Okay.
Because then whatever tool you would use after, you know, like people are gonna have their preference, you know, like either if you're using like IDA or Ghidra or like only debugger, or like there's some other debuggers, you know, that are like being released that are like pretty good too. Like there's a lot of tools, you know, like Binary Ninja, etc., etc. So I mean, like the step number 1 is to understand like assembly. Either if you're gonna be reversing like ARM assembly, ARM64, like 32-bit, 64 bits, it's gonna be like completely different worlds. But once you have an understanding of like how things work, you know, like, but best is like I would not start necessarily with like malwares. I would just start with like small programs, you know, to understand how they work, or like studying like an operating system. I think is a good way to look at things, especially like if it's open source, you know, you compile it in whatever like platform you know, because if you have like the source, you know, you can compile it, you can get the symbols regardless if it's like Windows or Linux, and then it can help you to understand the code and to have a lot of context. And then you look at the source code, you look at the compiled version, then it helps you to understand things and to get context on a lot of those things. So that's how I would like start with analysis. I know there's like a lot of cool stuff also, like if you are into like software security, application security, there are things like CodeQL that had been released by GitHub, which is pretty interesting. I spent some time to like study it a bit like this summer to understand how it works. Basically, you compile an application. It even works with Windows kernel, not Windows kernel, Linux kernel. Maybe Windows kernel at some point in the future. But like, let's say like any like open source application, it creates a database, and then you can type your own like query, and then you can create like sort of rules out of it to say like, oh, is that check done after that type of check or after a call? Is this around? So it's a good way to abstract like code in general. And I think actually, I think it's Bas Albert who is giving today a presentation at POC, a Korean conference, about how they've been using like CodeQL for, I forgot which application actually. But it's something, it should be like pretty good. That's one of the tool that's getting a lot of like traction like this year, because like they're providing a completely new paradigm to like looking for bugs, you know.
Oh, perfect. I believe that's among the lessons I need to go back to class too.
Which class?
I went, with regards to assembly, it's something I've really left out for a long time, and I might need to go back to class for that. And also, yes.
I mean, yeah, I mean, like back when I started to do like reverse engineering, it does make sense. But now the question is, actually, like, I'm not sure of the answer. Like, is it still worth like learning like reverse engineering now? In a way, yes, because like it helps you to understand how software is working. But then you have like all those new cool tools like CodeQL, those new languages like Rust, you know, that help you like to because they're formally verifiable to give you like a good paradigm, you know. So debugging is slowly like changing. Like debugging like now is completely different than before. So like if I would start now, I would definitely like spend time on like learning Rust, learning how to use tools like CodeQL, because you can use them on different type of languages like JavaScript or like C++ or anything. And you know, and I would be really focusing on that, because if you can write like secure software, or if people are migrating like, you know, from like C++ to Rust, which is going to happen more and more over the next years, it's going to be a very niche skill, but the value that companies are going to get out of it and people is going to be like pretty good.
That means there's a lot of evolution with regards to what we do right now, and it's up to us to keep up with what is changing.
Yeah, exactly. We have a bunch of questions also from the chat actually. Do you see the chat, the YouTube chat, by the way, or not? Do you have access to it?
Yes, I have access to it.
Okay.
Yes.
I still haven't checked the chat. I'm checking now. There's Laura who's saying, as listening to, I'm reading any sentence with more than 4 words. Laura was listening to the recent episode of Darknet Diaries on the Olympic Destroyer. I think you will see more of that, and we definitely need more malware analysts. Yeah, definitely a good point. There's a lot of also like those stories are becoming more and more public now, because like I mean 10-15 years ago, you like if something would happen, it would like be really like almost undercover. Like now, like because of the dystopian like reality we are in, you know, like all those stories are like really like not like cyberpunk stories, but it's a theme that's really like more and more common. So every time there's like a big hack, you know, like with the election or disinformation or anything related to like those things, like people are really really liking it.
I can read that for you. What has been Felix Atandi is asking, what has been some of your challenges with regards to cloud forensics as compared to local memory forensics?
So for I assume you mean cloud memory forensic, because cloud forensic also it's an interesting like field. So in general, I really call it like memory analysis because it's a larger like spectrum. But I would say like for memory analysis in the cloud, I think there is more use cases because you can cover like more since you don't have like physical access to the machine and there is like limited things that you want to be able to collect. I do think that memory analysis for like cloud environment, Linux or Windows, is very interesting. But in terms of challenges, the main ones would be like probably around like around Linux, which I would say because there's so many like different distribution now, and but then that's that's something, for instance, that for like products like the one we are developing like Stardust, that's things we're like working on, so like users have easier life, so they don't need to worry about those things. And for cloud in general, I would say like scalability, because some servers can be like really big. You can rent like some server with like half a terabyte or 1 terabyte of RAM. So you need to think of like how you gonna analyze things in a different way. But it is a good question, because if you just look at like cloud forensic or cloud incident response in general, I think it's still like an early field, and people like you are saying, we're still like thinking of it as the local way of doing things does not apply really anymore, because a lot of environments are different. Like let's say if you have like some Kubernetes cluster, all those things, this is like really cloud specific. I mean, you can have like local Kubernetes clusters, but most of the time they would be hosted on a cloud provider. And to analyze and everything, like it is very different than like a local system. And I think even now, like Microsoft was open sourcing one of their operating system. Let me check, what was the name? They called it CBL Mariner. Apparently that's like the base OS for like for Azure Kubernetes services. But yeah, there's a bunch of different things. There's more like OS than the one we know traditionally, especially on the Linux side, because everyone is gonna do their own fork, their own flavor, which makes things a bit more challenging.
Okay, maybe add something to you for that.
Yeah.
Oh, sorry. I wanted to ask, with regards to cloud-based memory forensics, what can we add to containerized environments like Docker, Kubernetes, and elements around the area of microservices?
A good question. I'm actually thinking of doing a video on the topic. We're just like fixing some stuff on our side, but I'm thinking of doing like something around it. So the short answer is, at the end of the day, if you use like Docker containers, most likely you would use them on like Kubernetes. And if you have Kubernetes nodes, they're gonna be like either like Windows or Linux. In terms of like asset inventory, your cloud provider should like be helping you to do that in that sense, because so if you use like AKS or for instance Azure or Kubernetes service, you can list and scale your nodes, for Windows and Linux. And now they are reaching a pretty good like maturity level. But then the information you would want anyway at the end of the day is you want to have access to the main node, so you can look at all the containers and be able to analyze them. On Linux, it is okay because you just have like Linux application, but now on Windows, for instance, depending if you have like the hypervisor, so if you have like those silos, with the Pico processes, etc., it is. I mean, like a Windows OS now can look like completely different, you know. Whereas like Linux OS is like being like very like focused and targeted for like specific use case. So in terms of like what you want to collect, so that's one of the reasons I think memory analysis is more relevant now, because there's so many things that we need to collect, but we are not sure of what to collect. You know, like for like logs. I mean, in theory, like logs, you know, for like Kubernetes and etc. You should be able to forwarding like the logs from the containers like directly to like your whatever like solution you're using, or if it's like an Azure Log workspace or a different SIEM or whatever. But they would be mainly like DevOps related. Most of security people don't have that much knowledge about like cloud in general to give like good insight around it. So most of the DevOps people would have to think of security in that sense, because like people who have no background in like software engineering or cloud architecture, but who are still in security, is like completely different. But since there's like so many things that we're not sure of what to collect, like I was saying, I think memory analysis is very important, because you just get the memory of the machine and then you look at whatever you need to collect, you know, afterwards. And if there are things you missed, at least you have the memory of the machine and then you can look into it. It was like if you go for like specific like artifacts, which is fine, you may miss things. For instance, for like some processes, you know, like imagine if you have someone to collect an artifact, but it's running from within the container, and they completely miss the file, you know, like all those things, you know, in that sense.
That's quite interesting. And mostly, I believe with regards to DevOps, we need to, as the security personnel or the security professionals, need to find a better way to integrate with the pipelines that they have, because it's once they want to go to production at any moment. So we need to find a better way to integrate directly to the DevOps way of working. Yeah. So among the questions on chat, I believe for Benasir, where maybe you join the communities that we have. That would be SHEHACKS, meaning Africa Hackathon, and also there's a group called InfoSec and Forensics. So with that, you'll get a better mentorship and a better ground to learn more about penetration testing. And
you can always join the Discord server if you want to ask questions to people on the Discord link that you see on the top right corner here before my finger disappears. There is there is a link. You can just like join it, and you would have access to like a bunch of like people who are more than happy to mentor.
Perfect. I believe Matt himself is a community manager for OpCode. So with that, as he said, join the OpCode, the Discord link, so you can ask as many questions as you can. Then the next question is for Felix Atandi. It's as a multi-cloud incident responder, what tools can be used to do forensic audit and meet compliances as regards to cloud-based resources?
It is a good question, because you use the word compliance. I have like basic compliance like knowledge. I would be more than happy to have a chat with you, like to see if there is like a new like compliance requirement that have been raised or that you have seen, because it is a good question, because cloud and multi-cloud for IR, incident management, and risk assessment, there's definitely a lot of things to look at. The compliance, I think, are going to change a lot. So like it depends. So obviously the easy answer is like it depends, as usual. But in the case of Azure, for instance, you have the Azure Security Center, which is going to check all your policies within your Azure instance, and it's going to give you a score on the security procedures that you have in place. It's pretty good. They have their own compliance called Azure CIS, I think. Let me check. Yeah. And that one I found like is pretty good because it is specific to I'm posting it in the chat. It is specific to Azure. I don't know about GCP and AWS. I would not be surprised if they would do something like this. But what we see mainly now is mainly like policy checks for risk and compliance. But in terms of incident response, for forensic and incident response, because most of the compliance requirement we would see will be checking the policies, and that's it. Like, is that policy like in place? Tac, tac, tac. No, yes, no. But as an incident responder, depending of like how much say you have in it in the process, because most of the time, unfortunately, for like incident management and incident response, like people get involved like when there is already an issue, and then it's like best effort and what you can collect and what you can find. So personally, like, yeah, I'm a big believer in memory analysis. I do think there's more things that can be like be collected. That's gonna be like the focus on our platform, but at the same time I'm biased, you know. But the reason I also like it is because like if you're working with multi-cloud environment, which is like most of companies now, you would have some stuff on at least AWS and Azure most of the time. So you would need to understand like both platforms, so you need to have tools that work on both. In the case of like memory analysis or collecting information for virtual machines, I mean, we can talk more about it in the chat, but for instance, in our CLI, for like the PowerShell CLI we have like a function for like AWS and Azure specific to deploy, dump it remotely to a virtual machine and send it to the platform for analysis. Which is something we want to expand later on. But yeah, like on AWS, you have this thing called like SSM for like launching like command remotely. On AWS, no, on Azure, I forgot the name, but it's just something similar. It's like remote PowerShell script or something, which can be used. But that would work only for like virtual machines mainly. For like Kubernetes, like there's some limitations. I think we'd have to connect directly.
Maybe I can pick up on the aspect of AWS. For AWS, we have tools called Guard Duty. So for Guard Duty, it's able to give alerts to the SOC team that you have, or it can alert on the specific metrics on the different intrusions that you're going to have for your system alerts. And then we now have CloudTrail that's able to keep watch on the different changes that are happening to either your Kubernetes services, the different microservices that you've set up in your environment. So with that, you're able to have a better metric level. And then there are some new names I found with regards to managing the different DevOps environments. Among them is something called Prometheus and Grafana. So those are tools that you can use for logging and management. Those sounds like movie names, but it's something that you use for monitoring and logging for the different services you have. So with that, you're able to have a better metrics with regards to incident response in your environment. Yeah. So our next one, I believe, is how much does cloud-based memory forensics contribute to cybercrime cases with regards to an expert witness? Maybe Matt, you tell us more about that aspect.
Good question. So that's also another reason why I don't say like memory forensic and I say memory analysis, because forensic is really like law enforcement related. was like mainly tend to focus on what's related to like threat hunting and incident response for like companies, which does not necessarily like involve like a legal process or like expert witnessing and everything, but that's something I'm not familiar at all. So yeah, like even like in general, like cloud, like yeah, like for like cloud issues that are like, you know, like involving like crime, I think most of them were like probably like the S3 buckets, you know, with AWS when they were not password protected, etc., and being public. So I think like for like memory forensic and memory analysis, I would assume there is probably like none using leveraging that at the moment, because most of the incident response incident responder and like process will probably be completely like out of scope for them.
Okay. Thank you for that. Maybe for I believe this is the last question. Someone has mentioned about the code QL you had said earlier. So he asked, Ahmad, yeah, asks what other tools would you suggest for white box pen testing, particularly Dust tools?
Well, if you're a software engineer, like the compiler sometimes has some good options, and then it depends if you're doing like system development or web development. Like if you use like, let's say like Node.js, like you can audit like the packages you're using. But no, like for instance, GitHub is doing it automatically for you to like look at the package version that you're using. But otherwise, there's no other tools that I would like strongly suggest. To be honest, I think CodeQL would be the only one where I would give like a strong recommendation because of its design, and like I think like it has a huge potential. Because regarding the other tools, I do think like they're probably not as flexible as CodeQL, and probably won't be less efficient.
Nice. I believe we've answered your question, but there are a lot more tools that you can explore online. So maybe we're almost about to wind up. Maybe I ask our last question. So with regards to what we've discussed, what are the best ways we can, how do I call it? What are the different advices you can give the members that we have today for this session?
What's the question? What the for today's session? What?
Yes, with regards to the session we've had today, what advice can you give to the members we have with regards to building their career in malware analysis? Yeah.
I mean, like, if they're starting now, is it a good question actually? Because if I would start like security in general now, where would I focus on? Because you know, like there's a lot of things, you know, like let's say even malware analysis, you know, I mean, it is important, but I don't know how relevant it's going to be in 5 years, for instance. I mean, it's still going to be like relevant because we're still going to have malware. But then there is like so many like new fields that are like popping up, you know, like DevOps, for instance, and now you have like DevSecOps, or like we're just discussing in the chat, you know, about like a multi-cloud environment, because there's also like new problematic appearing. So yeah, malware analysis, I would say like just like if you want to do like malware analysis anyway, like the main skill you need to know is like assembly. Like if you understand assembly, you know, to use like a disassembler and a debugger, that's gonna be like your baseline for like the skill set, and then you're gonna build up in competence around it. But at the same time, there's also like so many like new fields that are like worth looking at, you know, like all the cloud security aspect in general, you know, because now like the only thing people are doing now is just like checking on policies, and that's it. So like cloud security architecture or those things, because I think like more, especially now if we look since the beginning of the year, more people are like moving towards like cloud and doing like quote unquote like digital transformation because of the pandemic. So there's like also definitely like new fields that are like appearing that are also worth looking at. So I would also like keep an eye on what's happening, like outside of like malware. But yeah, malware, like I would say, like it's pretty straightforward, in that sense, where like you need to learn assembly, you need to understand assembly well. You decide kind of more or less which platform you're gonna focus on. Is it gonna be like mobile malware analysis, Windows malware analysis? No, Linux. There is a huge gap also. So if I would get into like malware analysis now, I would like do more research on Linux, because a lot of things didn't change in like 15 years. And if you look at like all the EDR security protection on Linux is very weak compared to Windows. Although in cloud, most of the operating system are Linux. So we're in a situation where like most of the OS are Linux. And in terms of like toolings or competencies, we don't have much for like analyzing Linux. Whereas like on Windows is like overcrowded, There's like 20 different EDR for Windows. Like there is like different SIEM, like event stuff, like forensic tools. It's very crowded, and you feel like you're always missing a tool or whatever. Whereas like on Linux, there is a huge like it's very quiet. So if I would do malware analysis now, yeah, I would probably like focus more on Linux though. I definitely learn assembly, but I would focus more on Linux, because most of cloud is Linux anyway. So yeah, like Linux also, like because on Linux you see also more rootkits, like the I don't know if you remember the report from the NSA CIA that happened for like Rob, I think. I'm trying to retrieve the report. Yeah, I just found it. I'm gonna post it in the chat. It was about a Linux malware that they found, and yeah, so that was a pretty interesting case. And in terms of like malware itself as a rootkit, it's a good. I mean, the report itself is like pretty weak. It does not give you much information. It gives you some information, but you'll see that there's a lot of pages, but at the end of the day, it does not say much. They are more or less the same when it comes down to malware. So we'll do like some research on like Linux malware and Linux rootkit actually, because we're probably gonna see more of them since like it's so complicated sometimes to install stuff on Linux, and most of the things we see are like mainly like DevOps tool. For instance, like OS query is good. You can use it to like get basic information, but if there is a rootkit, like you will not see it. It's not gonna be useful for like threat hunting. It's good as an IT tool, as an IT utility, but it will not give you like some strong like output. I see a question about what about Golang malware. I mean, to be honest, if they're written like in in PowerShell or like in Golang or in Rust or in C++, yeah, it really doesn't matter that much in that sense. You'll still like see like how it's being used. It's like people who used to like write code in Delphi, you could still like disassemble it and have an understanding of it. Or even like, let's say if you have like a malware in .NET, there's like the .NET assembly, which is like the MSIL. But no, there is like really good tools for it that completely enable you like to like decompile the code directly. I mean, you can write a malware in any language because you're gonna get a binary at the end of the day, and if you have a binary, like it can run on the machine. So yeah.
I believe this has been something great for today, and I can't. There are not more questions I can see. Yeah, so there's nothing more from my side. Maybe as an appreciation to you, Matt, for taking us through this session. And I believe we have all learned something today. And with regards mostly to what we've discussed around malware analysis and a little bit of the cloud aspect to what we do to cybersecurity nowadays. Yeah, pretty much.
And yeah, and if you have more questions or like that you didn't have time to like ask or anything, just come over like on Discord, and we can just like continue the discussion over there. Trying to keep the Discord server like up and running. I've been trying to convince Laura and Eve to join it, but they say like, oh, it's too modern for them, so they don't. Do you remember? It's like, oh no, we're only using WhatsApp with a WhatsApp group, you know.
We'll consider that.
I mean, there is a SHEHACKS channel already, yeah. So technically, like, yeah, you guys are on Discord.
Yes.
But yeah. Cool. Yeah.
Thank you so much.
No worries, no worries. Thanks to you.
Yes.
Sounds good. Let me let me say